The moon has actually been escaping from the Earth, but it can never get away. What's more terrifying is that if one day it really runs away, all life on Earth would begin to head towards extinction within 72 hours. Oceans will go out of control, tides would disappear, the Earth's axis would wobble like a drunkard, and the seasons would completely collapse. The reason the moon hasn't run away is due to a cosmic level miracle of balance. The Earth pulls it with gravity, and the moon uses its speed to break away from the Earth, with the two forces perfectly balanced. This tug of war has lasted for 4.5 billion years. But here's the problem. The moon is quietly slipping away at a speed of 3.8 centimeters per year. This speed seems slow, but if you do the math, in a few billion years, when it gets far enough, the Earth will completely lose control. Before discussing why the moon would run away, we need to first understand how it came to be. The answer will refresh your understanding of Earth's origins. 4.5 billion years ago, the solar system was in chaos, with giant celestial bodies speeding everywhere. At that time, a Mars-sized planet collided head-on with Earth at a speed of tens of kilometers per second. The impact was equivalent to all the nuclear bombs on Earth exploding simultaneously a trillion times. The Earth nearly shattered, and a large amount of debris was thrown into space, floating, gathering, and colliding in orbit. Tens of millions of years later, these fragments coalesced into a sphere, which is the moon. That's right, the moon is essentially a piece of Earth that was knocked off. It is Earth's child. Yet from the moment it was born, it started to drift away. So why, after 4.5 billion years, has it neither drifted far away nor crashed back? The answer lies in the most exquisite balance of the universe, orbital speed. Imagine the moon as a high-speed cannonball with Earth pulling it down with gravity, while it simultaneously races sideways at about 1 kilometer per second. Each time it's about to fall toward Earth, its sideways speed flings it away. Thus, it neither falls nor escapes, forever orbiting around Earth. This state is called an eternal cycle of free fall. Simply put, the moon has been falling towards the Earth for 4.5 billion years, yet hasn't gotten an inch closer. What is even more terrifying is that this balance is entirely a cosmic coincidence. Scientists have calculated that if the moon's initial speed was slightly faster, it would fly into space, never to return. If it was slightly slower, it would be pulled by gravity to crash into Earth, wiping out most of the atmosphere. The fact that we can stand here and talk about the moon is thanks to a 1 in 10,000 cosmic lottery. Since it won't collide, what's the deal with moving away by 3.8 centimeters each year? The key lies in tidal forces. The rise and fall of seawater are due to the gravitational pull of the moon, but Earth's rotation is much faster than the moon's orbit. The raised seawater always runs ahead of the moon, and this leading water bulge gives the moon a slight forward gravitational pull, gradually accelerating it. The faster the speed, the larger the orbit, and the farther the moon moves away. It's not that it wants to run away, it's the Earth's oceans unintentionally pushing it. And the moon's gravity is also putting the brakes on Earth. Billions of years ago, a day on Earth was only 6 to 8 hours long. As soon as you opened your eyes, the sun would set. It was the tides that consumed the rotational energy, extending a day from 6 hours to the current 24 hours. The moon is Earth's brake pad. It slows down Earth's rotation, stabilizes the climate, and makes the proliferation of life possible. It is also Earth's stabilizer. The Earth's rotational axis is tilted at 23.5 degrees, which creates the season. This angle remains stable thanks to the moon's gravity. Like a hand, it steadies the Earth like a spinning top. Without it, the axis would swing wildly between 10 and 45 degrees. The North Pole could become a desert, the equator could be covered by glaciers, and every few hundred years, it could completely reverse, making it impossible for any life to withstand such extreme climates. The moon is still acting as a shield for Earth. Its surface is covered with craters, each one representing an interception for Earth. Over billions of years, it has blocked countless deadly impacts with its scarred body. If it weren't for it, the impact that caused the extinction of the dinosaurs 66 million years ago would just be the norm. Speaking of which, you will find that everything the moon does is exactly what Earth's life needs. Applying brakes, stabilizing the Earth's axis, blocking impacts, creating tides. Missing any one of these, and Earth could be a dead planet. And all of this originated from an accident 4.5 billion years ago, when a planet called Theia collided with Earth. It shattered itself, leaving behind the moon, and then vanished in time. The moon became Earth's most loyal companion, orbiting for 4.5 billion years without stopping. However, it quietly moves away by 3.8 centimeters each year. This number seems insignificant, but over a billion years it amounts to 38,000 kilometers. Its protective force is gradually weakening. Scientists predict that in over a billion years, the Earth and the moon will reach a new balance, and the moon will stop moving away. By then, a day on Earth will become 47 hours. But that is a matter of the distant future. For us, the moon is still there. Every night, it reflects sunlight to illuminate the night sky. It steadies the Earth's spin, ensuring the seasons arrive on time, and it spreads its cratered body to protect all life on this blue planet. The moon we look up to hides behind it 4.5 billion years of companionship and a cosmic tug of war that will never end.